All right, so we are starting with algorithms and flowcharts today. We are looking at algorithms and flowcharts. Last week, we looked at the concept of computer programming, where we talked about um, how computer programming languages, what computer programming is, then programming languages, how we can relate them to the natural languages we have. We also went on to talk about the evolution of programming languages, how programming languages started, talking about the binary and machine languages or machine languages. We talked about assembly languages. We talked about the procedural languages. And then lastly, the object-oriented languages, the object-oriented programming languages. Okay. So today we want to look at algorithms and flowcharts. Algorithms and flowcharts. So I believe most of us, the first thing you want to learn or you are thinking of learning in this course is basically to start writing program, okay, from your first day of this course. Okay, but programming doesn't work that way. Okay? So way before you start writing a program, the first thing you need to understand is that programming is about problem solving. Okay, problem solving. And how do we solve problem? We solve problem in programming by means of coming up with algorithms. Okay, coming up with algorithms. Now, these algorithms are ordered, okay, sets of steps, unambiguous steps that you need to solve a problem. Ordered set of unambiguous steps that you need to solve a problem. Okay, so you don't just see a problem and as a programmer, software engineer, developer, immediately start writing your program in whichever language you know and start solving the problem. No. Okay. There are things that you need to do first. Okay. And one of them is to come up with an algorithm. Now, one thing about algorithms is that they are independent of programming languages. Okay. So it doesn't depend on your knowledge in a programming language to be able to come up with an algorithm for a problem. Okay, it's independent of programming languages. So you should be able to write an algorithm that's a set of steps, okay, to solve a problem. Someone should be able to take your algorithm and implement it in any programming language. Okay, that's if your algorithm is efficient. You should be able to take your algorithm and implement it in any programming language. Now, an algorithm, bringing it down to our level for us to understand, basically has to do with, let's say you are a chef, okay, and you you are supposed to prepare a particular meal, okay. There are set of ingredients and things that you need before you prepare the meal. And there are even processes that you need to follow to prepare that particular meal. If it is lice soup you want to prepare, it has its procedure, the ingredients that you need to prepare the lice soup. If it's a granule soup, you have a procedure that you follow. Okay, not necessarily the same procedure for preparing maybe lice soup, or maybe not, or let me just say, not all lice soup have one unique procedure in preparing them. It may vary. Okay, so Aaron can have a procedure or steps that he uses to prepare his lice soup. Okay, um, let me look for another person. Maybe Blessing also has a way of preparing live soup. Okay. But the end product is that they all have prepared live soup. Okay. So algorithm is of the same flow where you have various steps to prepare or to come up or to solve a problem, various steps. Okay. And like I said, it's independent of a programming language. Okay. So for instance, you've been given a problem, okay, to develop, or let's say um, a problem to say to calculate the area of a circle, okay, to calculate the area of a circle. Now, with that problem, you first need to know the formula for calculating an area of a circle. Okay. Now, once you know that formula, you'd ask yourself what goes into calculating the area of a circle. Are there some values I need to enter as inputs in order to calculate the area of a circle? Okay. Are there some variables that I need to know of? How do I go about it? Okay. So you first have to make all those inquiries, find out what your input is, what is going to be your output, how you are going to put that formula together to compute, given the inputs, compute it, and then you get your output. Okay, so these are all ways of brainstorming and coming up with steps to accomplish that particular task of calculating the area of a circle. Okay. So briefly, that is what algorithms are about. Okay. That is what algorithms are about. And it's one thing you need to know as a programmer, as a computer scientist going forward, because it will apply in almost every course that you learn. Now, there's a course in level 200 known as data structures and algorithm. Okay, that course is going to delve more into the concept of algorithms and how to analyze them. Okay, how to design and analyze the algorithms. Okay, but our level here is just to give you that foundation, okay, for you to know what algorithms are about and how to write them, how to write the algorithms. Now in level 200, you now learn how to analyze these algorithms, okay, which is very, very key as a programmer. Okay, now someone will say, why do you need to analyze an algorithm? Okay, I don't know if you've watched videos or series on maybe a cooking competition. Okay, so back to the example on cooking competition, and maybe about three groups of people cook. Okay, and um, they are being evaluated. Okay, yeah, whatever they cook is being evaluated. Okay, so you can tell whether someone added more salt, the salt is too much, okay, how long the person took to cook, okay, the ingredients the person had, and how efficiently the person managed those ingredients in the meal. Okay, so these are all things that will be analyzed, and then they'll say that, okay, this person or person A's food tastes better than person B and person C. Okay, so the same way algorithms can be analyzed, okay, to solve problems. Sometimes it can be based on the complexity in terms of the time. Okay, how long does it take for that algorithm to run? Okay, so there's a way in which that can be handled, that can be analyzed. Another way too has to do with space. Space, we call it the space complexity. So how much space does your algorithm take? Okay, when running. Okay, so these are things that you learn more about um, in level 200 in algorithms and data structures. Okay, all right, so let's come back to the foundational level. Okay, we've talked about what algorithms are. We said they are a sequence of steps to solve a particular problem. Or, Giovanni, please don't write on the screen. To solve a particular problem, or it's an ordered set of unambiguous steps. Okay, if you say unambiguous, what it means is that the steps are clear, they are clearly defined. Okay, so they don't contradict each other. That produce a result or terminate after a finite time. Okay, that means that there will be a point where your algorithm has to come to a halt. Okay, you can't be cooking forever if you're a chef. Okay, cooking one particular meal forever, and it's not possible. Okay, there will be a point where the food will be ready and served. Okay, in the same time, algorithms will have a time where they terminate. Okay, and a finite time, terminate in a finite time. All right, so what are some of the characteristics of an algorithm? Okay, first, an algorithm may or may not require an input. Okay, an algorithm may or may not require an input. Okay, as we all know from basic ICT, okay, that every program takes inputs, processes the input, or the computer takes input, processes the inputs, and then gives you an output. Okay, but when it comes to algorithms or certain problems, not all of them will require inputs. Okay, for instance, someone says, write a program to display your name, okay, or to display something. Okay. So it is displaying whatever is being asked to display without accepting inputs into the program. Okay, so algorithms may or may not require inputs. Then each algorithm is also expected to produce at least one output. Expected to produce at least one output. Then algorithms are definite. Okay, that means they must be clear and unambiguous. Okay, they must be clear and unambiguous. And then it's also finite in the sense that it should be executed, okay, or terminated after finite number of steps. Your steps should not be should not be infinite. Your steps should not be infinite. Okay. So basically, those are the characteristics of an algorithm. Now, there are three control structures when it comes to algorithms. Okay, the three types of control structures when it comes to algorithms. Okay, and this will guide you depending on the kind of problem you have. Okay, now these three types of control structures. First, we have what we call the sequence. Okay, sequence. Now, the sequence structure usually are statements are placed one after the other, and the execution takes place from the top to down. What does this mean? This means that there are problems that comes in sequential form, okay, in a linear form. So one step after the other, and then it comes to a halt. Now, typical of those problems, you don't have to make any decision. Basically, you take in the problem or your solution has to do with maybe if there's input, take the input, process the input, and then you display the output. Okay, if there's no input, whatever has to be displayed will be displayed. Okay, so we'll look at some examples. So that's the sequential approach. Then we have the branching or the selection. In other books, you say decision making control structure. Now, in this decision making or branching or selection control structure, what happens is that there is a condition. Okay, you are given a condition. Now, according to that condition, a decision is made. That decision is either true or false. Okay. Now, if the decision, or in case the decision is true, that means one of the two branches will be executed or explored. But in case that condition is false, then the alternative um, statement will be explored. Okay, so we call that the if then, generally known as the if then is used to represent this branching or branch control structure. Okay, so a typical example can be you want to tell whether a student passed or failed a course. Okay, whether a student passed or failed a course. How can we determine whether a student in computer science class reading fundamental of computer programming has passed or failed a course? How can we tell? Okay. So there must be a condition, and that condition is that if a student scores 50 and above, okay, in exams, then that student has passed the course. Else, the student failed, okay, or otherwise the student failed. So that condition is given. So if we take the marks you had, let's say Felix Upori, okay, had 70% in exams. We are going to check that 70% by the condition. Is that 70% greater than the pass mark, which is 50? If it is greater than or equal to 50, then we are saying that what Felix Ofori passed the course. Otherwise, if it's less than the 50, then Felix failed the paper or the course. Okay, so that 70 is greater than 50. So Felix passed the course. Okay, so that is how the branching or selection control structures work based on decision. And that decision, is it true? Is it false? If it is true, it executes the statement. Okay, so that is how, that's another control structure. Okay? And the third of this control structure is what we call the loop or looping or repetition, okay, or iteration. Okay? Now, this type of statements are executed repeatedly based on what we call a certain loop condition. Okay, they are executed repeatedly based on a certain loop condition. Okay, so maybe you are writing a program and maybe a particular aspect of the program, you want it to be repeated. Okay, you want it to be repeated maybe 10 times. So maybe we have about 200 students in the class and we want to determine whether the 200 students passed or they failed. So we want to repeat the conditional parts 200 times to tell for each student whether they passed or failed. Okay, so that is a typical example of a loop, repetition, or the iterative control structure. Are we all here? Okay. All right, so is there any question? Anyone with a question? If you have a question, just raise your hand. If you have a question, you can raise your hand, and then I'll allow you to ask your question. Eric Kodro, do you have a question?
Yes, sir. Please, I have a question.
Okay.
Please, concerning the branching or the selection, you were saying it uses the true or false, and I wanted to know, is it the same as we used in Excel when you are, let's say, you are grading students, when you want to input, if a student had, let's say, 90, the
Student had A.
Maybe 90 out of 100.
Then you give the student A.
Yes, please. If the student had, let's say, below 90, the student will have B. Is it the same thing as the branching or the selection?
Yes, it's the same thing.
Oh, okay.
Yeah.
Thank you, sir.
So that's the same approach. Yeah.
Thank you.
Okay. All right. You're welcome. Any other question? Please, I've asked you to rename yourself, your full name with your ID. So the person with the name Big Jamal, and others who are using their iPhone name and all that, Zoom user, and so on. Please rename yourself. All right, so let's go on. So, like I said from the outline, there's one of our topics you look at, which is control structures. Okay, so I'll go to that part quickly. There's a diagram there to explain the control structures, the three types of control structures. Okay. So as we can see here, the image we have here, this particular one, is a typical example of the sequential or the sequence statement. Okay, so they are in a linear form. So there's the first statement, second statement, okay, in that linear form. from beginning to end. Okay. Then we have this one here, which is the branching selection approach. Let me just circle that for you to see. So this is the decision-making one, or what we call the branching statement or the selection statement. Okay. So with this one, we call this the decision symbol. Okay. So in the decision symbol, you have your expression, which comes in the form of the condition. So did the student score more than 50 or more? If it is yes, then it will say the student pass. If it is no, then the student failed. Okay. Now there can be multiple conditions. So for instance, Eric's question on grading. Okay, let's say we have, please don't write on the screen. Is it Boedu? Stop adding images to the text. If you can remove it, the arrow you just added. Okay. All right, so like I was saying, we have the Eric's question, which was about grading. We have grading, so maybe A, B, C. If you had A, it means you scored 90 or 85 to 100. If you had B, you scored maybe 80 to 84. If you had C, maybe 70 to 79, and that's order. Okay, so this is a scenario where you have multiple conditions. Okay, so there's also how you can handle that in the program. So if the first condition is met, that task is executed. If not, it goes to the second condition. If second condition is false, it moves to the third condition, and so on until if none of the above conditions are met, then it gives you the last option, or otherwise it will execute the last option that is available. Okay. So that is what we call the branching or the selection or decision-making structure. And then finally, we have the loops. We have the loops. Okay. So with the loops, there's also a condition. There's also a condition. Okay. So if that condition happens to be true, let's say the condition is saying that you want to run this program maybe 10 times. Okay. Now, once the value, maybe you want to run it for 10 students. Okay. You want to calculate the grade of 10 students. So whilst the count is still ongoing and we have the first student, if the first student or that first student, which is number 1, is less than 10, if one is less than 10, that means it's true. Then it will execute the statement and then come over again, check for the second student, if that is also true. So this will continue until it gets to the 10th student. Now, after checking for the 10th student, because we said the condition should be 10, it executes it and then add 1 to it. Okay. Now, the 11th student becomes the expression here, and the condition has already been set to 10 to accept only 10 students. Okay, so after running this 10 times, at the 11th time, it's going to be false because the condition is saying it should run that particular statement 10 times for 10 students. Okay, so that's what we call the looping control structure, or the iterative or the repetition control structure. Okay, so what they do is they repeat certain portion of the code while the condition is met. Okay, and then the decision-making one, which is the middle one, they execute a condition if the condition is met. Okay, then we have the sequence statement or the sequence structure. Okay. So this is a topic we'll come back to in the middle of the course, where we are going to focus uh, the syntax on C++. Okay, so let's go back to our algorithms. All right, so now let's look at the advantages of algorithms. Okay, so one is that an algorithm is a stepwise representation of a solution to a given problem, which makes it easier to understand. Okay, so you have a given problem, okay, and you come up with steps to solve that problem. So the algorithms, or an algorithm, gives a representation of a solution to that problem. Okay. Then algorithms also uses a definite procedure. So your procedure should be clear. Okay, the procedure is clear. Once it's clear and unambiguous, okay, there will be no issue with the algorithm. Then the algorithm is not dependent on any programming language. Like I mentioned earlier, it doesn't depend on any programming language. Okay, so when you write an algorithm, it is not like you are writing a Java program or a Python program or JavaScript program. No, it is just independent of a programming language. It does not depend on any programming language. Okay, so anyone, depending on which language you are good at, you can take the algorithm and then implement it in that language. Okay. Then it is also easy to understand. It's easy to understand. Okay. Now, every step in an algorithm has its own logical sequence. So it's easy to debug. Okay, if you say debug, it means a bug is an error. Okay, that may occur in your program. So if you say debug, you are trying to resolve that particular error in your program. Okay. All right, so now let's look at how to write an algorithm. How to write an algorithm. Okay. How to write an algorithm. So there are 4 steps here which we need to take note of. Okay. First, in order to write your algorithm, we just want to assume that you have a problem you want to solve. Okay, and by so doing, you need an algorithm. What is the first thing you do when you look at that problem? The first thing you do is to identify your inputs. Okay, what will be the input to that particular problem? Or does that problem require an input? If it does, what is the input? Okay, so we've been given an example here which says that you want to calculate the area of a rectangle. Okay, you want to calculate the area of a rectangle. Now, you need to take into consideration what would be your inputs to calculate the area of a rectangle. Okay, so in calculating the area of a rectangle, I need to know the height and the width of that rectangle in order to calculate or compute the area of the rectangle. Okay, so the height and the width becomes my inputs. Okay, so those become the input. That means that those are the values that you need in order to compute the area of a rectangle. Your height and then your width. Okay, they become the inputs because we don't know those values. Okay. So the first thing you need to identify is to define those inputs. Now, the next thing is to define the variables. Define the variable. So there are two types of variables. We have the input variables, and then we have the output variables. Okay. So in our context, the input variables are going to be the variables that we saw where we have our height and our width. Those becomes our input variables. Okay. Then when it comes to the output variable basically is looking at what you want to find, what you want to calculate. And in this context, we want to calculate the area of a rectangle. Okay. So the area here becomes our output. That is what we want to get for our result we want. Okay, after this computation, after solving this problem, the result we want is the area of a rectangle. So that becomes our output. Okay. All right, so he said define the variable. So the algorithm's variables allow you to use it for more than one place. We can define two variables for the rectangle height and the rectangle's width as height and width. Okay, or someone can also say H and W, where the H is the height, W is the width. Okay, now take note of this. It said you should use meaningful variable names. Now, this is one of the topics, naming of variables. Okay, one of the topics we will talk about extensively when we look at the basics, the basic elements in programming. Okay, now, so instead of maybe you using H and W, you can use height and width as the variable name. Okay, because sometimes not everyone will understand what the H means and the W, what the H and the W means in your program or in your algorithm. Okay, so it's just like back in elementary school when we are solving mathematical problems or SHS, we are solving math problem, core math, selective math, and we say that let A or let X be equal to the number of fruits that were stolen. Okay, and let B be equal to so and so. Okay, when you are solving a problem. Okay, so it's just like you doing the same thing. So where the X and the Y or the H and the W in this context mean the height and the width. Okay, so you have to make those things clear so that anyone who takes your algorithm knows that, oh, you are saying that H should be the variable for height, and then W should be the variable for the width. Okay. All right, so that's the second step. Now, the third step says we should outline the algorithm's operation. The algorithm's operation. Now, another word you see here in other books is the computation, the algorithm's computation, or you are computing. Okay. Another word you see is the processing. How is the processing taking place? Sorry. Another word you see is the calculation. Okay, so basically this part of your algorithm has to do with the formula that is given. Okay, if in any case, so maybe we are finding when you want to find the area of a rectangle, okay, area of a rectangle is given by the height times the width. It's given by the height times the width. So that's the formula. If you are finding area of a circle, it's given as pi r squared. Pi r squared, and so on. So the operation is looking at how you perform the computation. You have your inputs. You know what you are expecting as an output. So how do you now put the inputs into the formula and perform your calculation or your computation in order to arrive at your desired answer? Okay, so it says here that you use the input variable for computation purpose. So to find the area of a rectangle, we multiply the height and the width variable and store the value in a new variable, say area. Okay, so this new variable area, that is what we described here as our output variable. That's what we describe as our output variable. So it is now going to store your computation of height and width, height times width. It's now going to store that value inside the variable or the new variable or your output variable area. Okay. Then it also says that an algorithm's operation can take the form of multiple steps and even in branch, depending on the values of the input variable. Okay, so there are other instances where you may have to perform multiple steps in order to find the um, in order to find or in order to perform the operation, okay, of that algorithm, of that problem. Okay, so there might be points where you have multiple steps. There are points where the other control structures can come into play. So maybe the branching control structure where you have to make a decision. Okay, all that comes in to form the algorithm's operation, the computation. Are we all here? Then finally, as a step 4, we are looking at the algorithms. You output the results. Okay. So you output the results of your algorithm's operation. So it says in this case, the area of the rectangle output will be the value stored in the variable area. If the input variable describes a rectangle with a height of 2 and a width of 3, then the algorithm would output the value 6. So we are saying here that the height is 2 times the width, which is 3. And that will give us 6 as the area of the rectangle. Are we all here?
Yes, sir.
Okay.
Yeah.
All right. So this session is being recorded. Okay. So those of you who may have challenges with your internet and all that, it's being recorded and the video will be shared. The link to the video will be shared with you. I'll send them to your class rep so that you can go over and watch again. If in case you missed a particular session of the class, you can always go back and watch, or you want to watch all over again too. Yeah. All right.
Okay.
Any question?
Okay, sir.
Any question so far on how to write an algorithm? If you have a question, you can raise your hand. I saw a hand raised earlier in the chat. What's the name? Is it?
Please, I'm the one.
Please mute yourself if you are not speaking. So I see Achia Boatima. Your hand has been raised earlier. I didn't say you should turn on your camera. Who is J. Paulson Studios? Is that your name?
Sorry.
Please rename yourself. Just raise, there's a option for you to raise your hand. Okay, so you will see that down there. It's an emoji. Just use that. Okay. And then I'll notice it and call you. Yeah. So please rename yourself. The name we all know. The school identifies. Else I'll take you as an intruder and remove you from the class. Achia, is it Achia Boatima? Yes.
Earlier, when the guy was asking a question on the branching or selection about the grades,
Okay.
whether it is the same thing as the Excel. Earlier, I wanted to ask if the formula used in grading the people or the students, is it the same thing used in the branching or selection?
Yes. So what you do is, so it's up to you, the programmer, to understand that formula that is used in grading. Then you translate that formula into your program. Okay, so that is why we are learning these algorithms. So you should understand what that formula is. So if the formula is saying a student gets 85 to 100, then that student should be awarded A plus. If the student had 80 to 84, that student should be awarded A. Okay, so it's up to you, the programmer, to understand how this scheme of grading works. Then you implement those conditions inside your program, inside your branching or the selection control structure. You implement it there. Okay, and these are all things we are going to look at in this course. Is it Opuni Befi? Moses, eh? Is it Moses? Yes, Moses. You raise your hand in the chat. Do you have a question? Please, Prince, is it Madilo? Please turn off your camera. Okay. Then another person, Simon Akansa. Do you have a question? And the person who named him or herself, what, HP Core i5. Do you have a question? Can you rename yourself? Use your full name. Okay, if you have a question, you can ask. Then is it Awen? Uh, what's the name? Is that your full name? Is it Awen Nam or what? And who is that? Is that your full name? All right. So let's listen to David Atta. David Atta, you can unmute and ask your question.
Please, in the advantages of advantages of algorithm, you said it's dependent on any programming language, meaning it doesn't need the help of programming languages.
Yeah.
But does a programming language need the algorithm to function? Something like a programming language like QBasic.
Kindly check. It's not. It's not.
So David, right? So the advantage
Yes,
here is saying it is not dependent on any programming language. It is not dependent. So if you want to solve a problem, okay, you have an algorithm. The algorithm is written such that you don't even need to have an idea, okay? If you don't even have an idea of programming at all, you should be able to take an algorithm and understand it. That's why we say it's independent, or it is not dependent on any programming language. So I don't have any idea at all about programming. Okay. So, but I can write an algorithm. I know that if I want to find the area of a circle, first I need the value of the radius, which is my input. Then I'll pass it into the formula, pi r. Then I double or I square the radius, and then I get my output. Okay, I don't need to be good in programming to be able to understand that this is how I solve the problem of calculating the area of a circle. I want to find simple interests. Okay, I know that in finding simple interests, I need my principal, I need the time, I need the value of the rate. Okay, I don't need to be a good programmer to know that this is how to calculate simple interest. That's why we are saying it does not depend on a programming language. It's for you to brainstorm, look at what the problem is. Then you use your basic English knowledge and the use of your operators, okay, to come up with an algorithm or a step-by-step solution to the problem. It is after you've done the algorithm, then you can use the knowledge you have in programming to implement that algorithm in a particular programming language. David, is that clear?
Yes, please.
Okay. All right. So Ebenezer, your hand is up. Ebenezer. Ebenezer, we can't hear you. Okay, let's move to the next person. Is it Akantari one? What's the name? What's the name? You can unmute and ask your question. Help me with your name first. Is it Akanta what? Hello? All right, let's move to the next person. Shrey Gideon. Gideon Shrey.
Yeah, sir, good evening.
Yes, good evening.
All right, please, I want to ask if the algorithm, we can say that it's like a blueprint that the program is, you have a problem, then there's a blueprint that you are going to look on it to solve the problem. I don't know if we can put it that way.
Yes, we can put it that way. However, you need the algorithm will, in this context, act like the blueprint to solve to help you write your program. Okay, so yes, you can write your program, see a problem, and start writing the program. But that is not the ideal way in solving a problem as a computer science student. So yes, your algorithm can act as a blueprint for you to help you write your program. Kelvin Clenham.
Hello.
Yes, Kelvin.
Is, since the algorithm is not dependent programming, does that programming language is dependent on the algorithm?
Yes, every programming language given an algorithm. Okay, so maybe back to the example, finding area of a circle. Okay, I've written an algorithm to do that. Okay, so I can take that algorithm and implement it in Java, implement it in C++, implement it in Python. Okay, so how do I put it? As a computer scientist, you need to understand the algorithm. It is dependent, okay, or your programming language depends on it. Let me put it that way. Your programming language depends on it. Like I said, in level 200, you learn about the algorithms, how to analyze them. And these are things that you need. These are like the core courses you need as computer science students to appreciate, to really appreciate and know how these things work for every program that you write. The program might work all right, but it might not be computationally efficient. Okay, so it depends on your programming language, depends on your algorithm. It depends on your algorithm. Andrew Corte. Andrew, you can unmute and ask your question. Andrew, we can't hear you. Okay, so Ebenezer, you've typed your question. You said, does that mean that it is Does that mean for algorithm, it is going to be a pen and paperwork, no need for computer? Okay, that's a good question. A good question, and Wilfred is laughing. All right, so that's a good question. Okay, so yes, it's not necessarily the fact that you need paper and pen. Okay, you can start with a paper and pen. However, there are what we call notepads. Okay, notepads where you can write your algorithms in. Okay, you can write your algorithms in. It works with some words, some symbols, and some characters that you may have to use. Okay. But if you do it with paper and pen too, it's also good. Okay, but there are notepads in which you can write your algorithms. Just that it cannot be, you can't run it. Okay, you can't run it to give you the solution. The only way you can implement it is to use it in a particular programming language. That's how it can be implemented. All right, let's take the last question. Lots of hands are raised, but it looks like most of the question has to do with independent, the algorithm being independent. So let me take two more questions. So Francis Esiedu.
Okay, so I want you to briefly explain the meaning of algorithm in terms of our course.
Hey, algorithm in terms of what?
Our program, the program we are offering.
Oh, I've explained that already. I don't know if you joined from the beginning.
Yeah,
I've
but
explained that.
I don't really get it in terms of the advantages and then the rest. So I want you to briefly explain. I mean,
So what
what
do
it
you
does.
think? What do you think an algorithm is from all that I've said so far?
To my understanding, I think it's like a calculator for our programming languages.
It's like what?
A calculator, I mean, it solves problems, numerical problems to like a calculator. Do you get it?
Hmm. Okay, I get where your question is coming from. All right, thank you. Let me take one more question and then address it. So let me just pick at random someone. Abdullah.
Okay, yes, sir. So my question is it possible when writing an algorithm you may make an error or something? Is it possible
Okay.
that yeah? And if there will be a mistake, how do you go by it? How do you correct it?
Okay. All right. So let me address these two questions and then we continue with the our slides. So on Francis, your question. Okay, it means you've still not understood what we are talking about. Okay, basically we are saying that before you start writing your program. Okay, so what someone will say, I'm programming, I'm writing codes to solve a problem. Before you start doing that, the first thing you need to do is to understand what is an algorithm. Okay, so maybe you want to solve a problem. And when we are saying solving a problem, if you were with us last week, I said that most of the problems we are going to look at in this course are mathematical problems. Okay, so it doesn't mean that your algorithm is like a calculator. Okay, yeah, a whole lot of problems, but we start by looking at problems that are mathematical based, because going forward, those are the things you have to do as a computer scientist. Like I said, computer science is different from IT. Okay, the IT people, yes, they'll write programs, they'll do all that. But as a computer scientist, the main thing you need to know has to do with computation. Okay, how are these computations carried out? Okay, and the algorithm, given a problem, you are supposed to break that problem down into steps. Okay, so if you go back to the beginning of the material, I said there are step by step or ordered steps in solving a problem. Okay, so if you want to move from, let's say, Medina to Accra, ATU campus, what are the steps you need to take to get there? So those steps that leads you to your destination is what we call an algorithm. And in solving every problem as a computer scientist, you need algorithms. You first break the problem down into steps using your algorithm. Now, once you have those steps broken down, okay, once you have those steps there as various points, then you can take them step by step. And then if you take step one, you write your code in maybe Python or C++ or Java to implement that step one. You take step two, you write your code to implement that step two. You take step three, you implement your code, write your code, okay, to achieve what you have written as your step. Francis, is that clear?
Yeah, that's it. Thanks.
Okay, all right. And then Isahaku, your question has to do with whether you can make mistakes in your algorithm. Yes, definitely, you can make mistakes in your algorithm. Okay, usually the mistakes you make in an algorithm is not like sometimes you might not see it until you implement the algorithm in a programming language. Okay, sometimes it's not visible. It won't come to you as an error because it's usually written. Okay, you don't type it or you don't do it. You don't write it like a code that you are going to run. Okay, it's just step by step. It's like someone has given you a recipe book on how to prepare maybe fried rice. Okay, and maybe the person, because the person likes pepper, spicy food, gives you the quantity of pepper you should add to your fried rice. Okay, you will see it in that context as, oh, but why do you add this quantity? It's an error. Or sometimes you even prepare the food using the quantity the person has given, and you realize that after tasting the food, you realize that this quantity of this ingredient that you added is making the food maybe too salty because there was too much salt, something. Okay, so mostly with algorithms, you only identify the error after you, mostly you can identify it during the analysis when you're analyzing the algorithm. You can identify it, okay, but at your level, it is when you write the program and you implement it, then you identify that, oh, there was an issue with my algorithm. Okay. But there are some error that are maybe syntax based. Maybe you made a mistake with writing the formula. So for instance, area of a circle, pi r squared, and then you go and do it pi r. Okay. With something like that, you made that mistake. Instead of r squared, you did it r. So it's a mistake on your part. There are times you have to go into the program before you identify it. Those are technical. Others too has to do with when you are analyzing the algorithm. Okay, just a minute. All right, so basically that's it. Let's move on. There are a couple of things we need to touch on before we end. All right, so there's also what we call a flow chart. A flow chart. Now, I'd want you to, if you have your personal PCs, I'd want you to download this application. It's known as draw.io. Draw.io. Okay, you can have it downloaded on your personal laptop. There's also the online-based one. Okay, we are going to use it to implement the flowchart. Okay, so practically we will learn that. We'll look at it next week when we meet face to face. Okay, but have it downloaded on your PC at home or your laptop. We are making it available at the lab so that when we meet, we can use it for our practicals. Okay, so let's talk about flowchart. We'll come back to the algorithms. So what is a flowchart? Now, a flowchart is made up of different symbols which are used to design a solution to a problem. Basically, we can say a flowchart is the diagrammatic representation of your algorithm. Okay, so given an algorithm to solve a problem, a flowchart is when you now come up with a diagram with symbols to show how your algorithm works. Okay, so there are people who, now it's one good thing about computer science, okay, or programming, where it's not necessarily about the artifacts, okay, but you are looking at what goes into developing the artifacts. What it also means is you've gone to purchase a product, okay. Now that product will have in it what we call a manual, And mostly when you take the manual has some set of instructions, and mostly there are even diagrams that even shows you how you should use that product. You read the instruction, you watch the graphical representation of that artifact or that product you have, and how to even install it, how to even use it, and so on. Okay, so you need these things, the algorithm, flowcharts, to be able to appreciate what the actual outcome of your program will look like. Okay, so flowcharts are symbols used to design the solution to a problem. Now, this was introduced by John von Neumann, a mathematician, scientist, back in 1954. Okay, and it's still in use. It's been updated anyway, but it's still in use. It is one of the symbols or one of the diagrams, let me put it, that you need to learn or understand, okay, when it comes to programming. There are other diagrams, ER diagram, UML, class diagram, sequence diagram, a whole lot of them. Okay, but there's a course that will take you through this diagram. That's system analysis and design. Okay, but for now, what you need for this is what we call the flowchart. So what are some advantages of the flowchart? So the flowchart is an excellent way of communicating the logic of the program. Okay, the logic of the program. It's easy and efficient to analyze problems using your flowcharts. During program development cycles, the flowchart plays the role of a blueprint. So, Francis, the question you asked, okay, which makes the program development process easier. Also, after successful development of the program, it needs continuous timely maintenance during the course of its operation. And the flowchart makes program or system maintenance easier. Okay? So if there's an error, there's a bug somewhere, there's some maintenance issue somewhere, and you can identify it, when you go back to your flowchart or even your algorithm, you're able to trace where that error is coming from, and then you resolve it. Okay? Now, it's easy to convert the flowchart into a programming language or into any programming language, okay, just like the algorithm. So the flowchart is a diagrammatic or graphical representation of the sequence of steps to solve the problem. And those sequence of steps are your algorithm. So it's just you having a graphical representation of your algorithm. Now, to draw that, there are some standard symbols we use. There are more symbols, but we look at the standard ones that we use. So the first here, we have the oval shape. The oval shape, we use them to start and end the flowchart. We use them to start and end the flowchart. Then we have the parallelogram, which is used for input and output operation. So anytime you have to perform input and output in your program, we use the parallelogram. We have the rectangle, which is used for processing. That's the operations, the arithmetic operation, your formulas, where you have to do some computation and so on. We use a flowchart. Then we use the diamond shape for decision making. Okay, so if you remember the image I showed you earlier on the 3 types of control structures, you saw that 2 of the control structures had a diamond shape, and it was written in their expression. That's where your condition comes to. Okay, so anytime you see the diamond shape, it's for decision making. Then you have the arrows. Then you have the page connectors. So if you are working with multiple pages, then it goes with the off-page connector. So off-page connector, when you want to join, so it's more like you are drawing your algorithm on one page and you've exhausted that page. So you need to move to maybe another page. So you use these connectors, the page connector and the off-page connector, to show that, okay, this algorithm doesn't end on this page one. It continues on page two. Okay, so we look at how to use them next week when we meet at the lab. Then we have the predefined process. So predefined process is used when there is a function which has a multiple process to be performed, multiple operations to be performed. Then we use the predefined. Then we have the preprocessor. So the preprocessor usually comes in when there has to be a process to be performed before maybe another process is performed. Okay, so we use that. Then we have the last one here known as annotations or comments. Okay, so the annotations or comments just explain what is happening at a particular step of your flowchart. Okay, so if you are performing input, what are you taking as input? You specify them as an annotation. So annotation is like you writing a mathematical equation and you're saying, let X be this and Y be this. Okay, so you are just trying to define the properties you are using or explain what is happening at a particular stage in your program. Okay. Now, the language that is used to write an algorithm is simple. Okay, it's simple and it's similar to our day-to-day life language. It can be English if you speak English, it can be Spanish if you speak Spanish. It's just the simple English language. Okay, however, it uses symbols, it uses some special symbols and arithmetic symbols to write them. Okay, one of such symbol is what we all know as the equal to sign. Now, anytime you see this sign in a program, it is called, or you see this symbol, it is called an assignment operator. Okay, what we would all call equal to. It is called assignment operator. What it means is that it is used to assign a value to a variable. For instance, we say height is equal to 5. What we are saying is that we are assigning the value 5. 5 here is a value. We are assigning the value 5 to the variable height. So height here is a variable. Okay, so what it means is that we are assigning the value 5 to the variable height. Okay, so this is what we call the assignment symbol, or we also say assignment operator. Okay, so you get to the operation part of your algorithm where you want to implement, you want to write out your formula. Okay, so you say that maybe area is equal to height times width. Now, what it means is that the result you get after computing your height times your width, that value you get, okay, should now be assigned to your variable area. Okay, and like I said, we'll talk about variable extensively when we look at the elements, basic elements of programming. Okay, so it said the symbol, which is the assignment operator, is used in most programming language as the assignment symbol. The same has been used in all algorithms and flowcharts in this manual. Okay. So the statement C is equal to A plus B means that add the value stored in the variable A and the variable B, then assign the value, or store the value in the variable C. Okay. Similar to this, it means that add 1, sorry, this is 1, not I. Add 1 to the variable stored in, to the value stored in the variable R. Okay, then assign or store the new value of R, or store the new value in the variable R. In other words, we are increasing the value of the variable R plus 1. Okay, so take note of these statements. They are things that you see in the course going forward. All right, let's look at some mathematical operators. Now, these operators, you should know them very well because, like I said, most of the things you do in the programming has to do with computation and logic. Okay, logic. So understand these operators and when and how they are used. So the first of which we have here, Elisha, please don't write on the screen. Kindly undo what you just did then. Elisha, undo it. Elisha Agbodo.
Sir.
Yes, undo the mark on the screen, the red mark you have on the screen.
Oh, okay.
Yeah.
So it's a mistake, sorry.
Okay. All right, so we are talking about operators. Okay, so we have the mathematical operators. These are the basic arithmetic operators. So we have this symbol, that's a plus symbol, is for addition. We have the minus symbol, which is for subtraction. So A minus B. Then we have the asterisk, which is the star symbol we see here, is for multiplication. So in this context, if you are doing anything multiplication, you don't do the X sign, because the X will be seen as a letter, okay, a letter X. So instead of that, we use the asterisk, the star symbol on your keyboard for multiplication. Then there's no symbol like division symbol on the keyboard. We don't have this symbol on the keyboard, so we use the /. Panini Bedu. Panini, stop writing on the screen. What is it? Bani. Bani. Bani Bedu. Or him. Stop writing on the screen.
Okay, sir.
So we use a /, which you can see on your screen. We use that for division. Then we use the caret symbol, okay, which you can also see on your keyboard. We use the caret symbol for power, to find the power. So if you want to say 3 raised to the power, A raised to the power 3, this is how you write it, A caret 3. Okay. Then we have the percentage symbol here, which is used for finding remainder, what we all know in maths as modular arithmetic. Okay, so we use that to find the remainder. So those are the basic operators should know of. That's the mathematical operators. Then we come to what we call the relational operators. He is a part-time student. Do you have another class at 7?
No, sir.
Most we don't have any other class.
Okay. All right. So I'll take a bit of your time I want to finish explaining this concept so that when we meet next week, we are just going to look at the practical aspect of the algorithms and flowcharts. All right. So we have the relational operators, also known as conditional operators. Okay, so remember we talked about the branching structures or the selection or decision-making structures. Now, these structures work based on conditions, and these conditions use this relational or what we call the conditional operators. Okay, so how does it work? First, we have the less than. Now, the less than works like this. So A is less than B. So if, let's say, we write let A equals 2 and B equals 6. Okay, that will be A is less than B. And the answer we are going to get is called a Boolean answer, true or false answer. So that will give us true. That will give us true. Okay, sorry, B should be 6. That is true. Okay. Then we have less than or equal to. Now, we all know that this is how we write less than or equal to, but we don't have a symbol like this on our keyboard. Okay, so what is accepted is you introduce your less than sign and then you add the equal to symbol to it. So that makes it less than or equal to. So less than or equal to is this. So if, for instance, we say 2 is less than or equal to 6, what do you think that will give us? True or false? Anyone?
False.
Okay.
False.
Are you sure? Are you sure that will be false?
It's true.
It's going to be true.
True. It's true.
Okay, so it's going to be
I think
true.
it's true. Yes. It's true.
Yeah, it's true. It's true.
All right, so it's going to be true. Okay. Then we move to the next operator, which is the equal to. Okay. Now, like I said, you want to distinguish this equal to from this one. Okay, so in most programming languages, we use the double equal to sign to determine equality between two variables. Okay, so in this context, this double equal to is no longer, it's not assignment. This time you are trying to tell whether two variables are the same. Okay, so you can equally write it like this. You can equally say A double equal to B, and preferably I would want us to do it that way rather than the single equal to. Okay, so that is to say that is 2 equal to 6? And what would that give us?
False.
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 Then we come to the next operator, which is the not equal to. Now, anytime you see this exclamation mark, it means not. The exclamation mark here means not. So this means not equal to. Okay. So if we say 2 is not equal to 6, what would that give us?
True.
That'll give us true.
True. Sure.
True.
Yeah, true.
Yeah, true.
True.
That's true.
Then we take the next one, greater than. So 2 is greater than 6, which is false.
False.
And then the final one, 2 is greater than or
False.
equal to
False.
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 which is
False.
also
False.
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 Guys, take your
False.
time, man.
The force is too much.
all right. So I believe we all understand the relational operators and how they work. So when we start writing our branching statements and also our loops, you realize that we'll be using these relational operators a lot. Okay. Now, the next one we want to look at is what we call the logical operators. Logical operators. Now, these logical operators are used to combine expressions with 2 or more relational operators. Okay, they are used to combine expressions with 2 or more relational operators. Now, for instance, if we take the first scenario here, we have if we take the first scenario here, which is the AND operator, you can tell that we have A is less than B as one expression with the less than relational operator. And then if we come to this side, we have B is less than C, also an expression which is using a relational operator. Okay, so the logical operators are used to combine expressions with 2 or more relational operators. Now, what are these logical operators? First, we have the AND, then we have the OR, and we have the NOT. Okay, this, if you have learned in electronics, if you've learned gates in electronics, you should be familiar with whatever is being discussed here. Okay, these symbols are also used in electronics, gates, and also resistors. Okay, when you are doing your physics. So let's see how this works. Okay, now for the AND gate, okay, the AND gate executes a statement or only when both sides are true. Okay, only when both sides are true. Else it is false. So he said the result is true if both A less than B and B less than C are true, else it is false. Now, this is what it means. Let's assume we have this table. We call it the truth table. Let's assume we have this truth table, and we have here A and B. Okay, I'll use T to represent true, and then F to represent false. Now, going forward, another way to represent the true or false, true is given as 1, and then false is given as 0. In other contexts, true is given as yes, false is no. Richard, stop writing on the screen. Undo whatever you've done. Richard Apalu. So A and B, what would that give us? So if A is true and B is also true, then A and B is true.
True.
From the meaning we have here. Okay. If A is true and B is false, the explanation we have here is saying that both. So let's assume this whole statement here is A, and this whole statement here is B. Okay, so we have A and B. Okay. So it's saying here that if A is true and B is false, then according to this, which is saying both of them must be true, it makes this false. If A is false and B happens to be true, at least one of them is false, so both are false.
False.
And then finally, if A is false and B is also false, then the entire statement is false. Okay, so that's how the AND operator works. That's how the AND operator works. Okay, so if we assume that A is equal to 2, B is equal to 6, and then C is equal to 4. If we come into this, our equation, we are going to get 2 is less than 6. And 6, which is B, is less than 4. What would this give us? 2 is less than 6. That would be true or false?
True. True.
It's going to be true.
No,
2
Yes,
is
sir.
less than 6. Okay. So we
So
are
we're
going
giving
to
us
get
false.
true.
True.
And then 6
True.
less than 4 is also false.
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 Yeah.
Yeah, false, false.
So true
False.
and false will give us false.
False.
False, false.
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 Take your time and just raise your hand and answer.
False.
Oh, dear. This way is making noise.
All right. So let's move to the OR operator. Okay, so the or operator also is used to combine two or more expressions with relational operator. Now the or operator says the result is true if either A less than B or B less than C are true, else false. So what it's saying is that for the OR gate, at least one of them, so let's say if this is our A, let me use X and Y so that you don't get confused. Let's say if this is my X and this is my Y, at least one of them should be true for the entire expression to be true. Okay, so that's how the OR gate works. So let's write, see how we can represent that as well.
Sir.
In this form.
Sir.
Yes. Who is that? Romeo. Do you have a
Please,
question?
can you hit on the OR gate again? The explanation you just gave. Now, please, the explanation you gave about the OR gate right now, please, can you hit on it again?
Okay. So just pay attention. I'll do that again. All right. So what I said is that with the OR gate, I'm using X and Y. So I'm using X or Y. Okay. Now what it means is that your result will be true if either X or Y is true. So what it means is that the OR gate, at least one of them should be true. Okay, where the AND gate is saying that both sides of the expression should be true for your results to be true, the OR gate is saying that at least one of them should be true for your expression to be true. So let's say our X is true and our Y is also true. Okay, because both of them are true, it is true. It's saying at least one. So if two are true, it is true. Now, if our X is true and our Y is false, it is true because it says what? Either X or Y has to be true. So it is still true. Okay. Then if our X is false and our Y is true, then our X or Y is still true because at least one of them is true. Okay. And then finally, if our X is false and our Y is also false, then both X or Y are false. Okay. So let's put this in our example and see. Our example, we said A is what? A is 2, and 2 is less than, 2 is less than B, or sorry, 2 is less than 6.
6.
2 is less than 6, or 6 is less than 4. So A is less than 2 is less than 6 is true. It's true.
Yes.
Or 6 less than 4 is false.
It's
False.
So what would this give us?
True. True.
This will give us true because at least one of them has to be true.
Yes, sir.
True.
Okay. All right. So that is it. Then yes.
Please, I have a question. The first one, diagram. You said T, X is true, and Y is true. So they said result is true if either A, B, or B less than C are true. So doesn't that mean that when both of them are true, the result is false.
Repeat your question again.
On the diagram you made, say the X was T.
Which of the diagram? Is it the blue one or the red one?
Please, the blue one.
Okay.
The first two truths.
Yes.
So it said result is true if either A is less than B or B is less than C are true, else false. So isn't that trying to say that if both of them are true, then the answer will be false instead?
No, that's not what it means.
No.
Okay. What it means is that at least one of them should be true.
Okay, sir.
Okay.
Thank you, sir.
Okay. All right. Emmanuel Boateng, you have a question? And Bernard Mate, you have a question? Yeah, Emmanuel, let's go.
All right, sir. So what you've taught us now, does it mean that with the first operator, that's the end operator, it means if we have one of the statements to be false, it makes all the statements false, unless they are all true. That is when they become true.
Exactly.
And then for the or operator, it means whether one or either of the statements should be true. If it is true, then it means the statement is true. But if they are both false, then it is false.
Yes.
And then with the not operator, from what I'm reading now.
Okay. Yes, go on.
Yeah,
Even though
okay.
we've not discussed it. Please, Gifty, let's allow him to explain it, then we'll come to it.
Sometimes slow down.
Jacob.
Let me end it here because I wanted to say from what I'm reading, but let me end it here.
Your people say you should slow down, so just press your brake and park your car smoothly. Yeah. All right, Bernard.
Okay, thank you very much, sir.
Yeah.
I wanted to make just a quick question. Ask a quick question.
Okay.
So since we are all basing on the lesser than sign, are there instances where either, let's say, for the end gates, where the A is defined as, let's say, A is less than B and B is greater than C? Are there instances like that where we have situations like that, please? That's the question.
Yeah. In fact, there are even more complex situations that we can come up with. Let me just clear everything and let's try at least one. Okay. So still with the concept that let A equals 2, B equals 6, and then C equals 4. Like I said, the logical operators are used to group two or more expressions with relational operators. So it's like the first two examples we see here are using the less than. That doesn't mean it's always that case. Okay. So let me give you this scenario where we have A is greater than B and C is greater than or equal to A, or B is not equal to C, and B is greater than or equal to A. I need one person to take us through this. So Bernard, this is your question.
Okay.
So who wants to help us?
Let me try.
Okay, Godwin, go on.
Yes, the end statement. If A is greater than B and C is greater than A, meaning one it always compare to a group of words. So I can say A is greater than B is true because it's a separate. They were separate different words together.
Hey,
So
please, what you are saying is confusing me. Please go forward, go straight forward. We've told you what the value of A is, what the value of B is, what the value of 4 is. So
okay.
just replace those values and tell
The
us
value-
whether A minus B, A greater than B is true or false. But what you are telling us is confusing.
Okay, A is equal to 2 and B is
Okay.
6. So if A is 2, 6, then 2 is greater than 6 is false statement that or on that side, and C is 4.
So this
and
side,
A is,
wait, take your time.
yes,
So A is greater than B.
yes,
That means 2 is greater
is-
than 6 is what? False, right?
yes.
Okay. Then we have C is greater than or equal to A.
So C is 4
C
and
is
A is
4
2. Yes,
and A is 2.
yes.
So what would that
Which
give
is
us?
true.
This is true. Okay.
And B is equal to C. That's
B is not equal to C.
not okay. It's not equal to C. That 6 is not equal to 4, and that one is true.
Okay. And then the last one here.
Greater than or equal to A. That's B is 6 and A is 2.
So what that give us?
One is false.
Are you sure?
Please.
Are you sure? It's false.
It's false. It's true, sir.
This is true,
It's
sir.
true. Yeah, it's true. One of them is true. So it's true.
So, okay.
So I think it's true.
All right. So
okay.
This is going to be the breakdown. We have F, that's false and true. Then we have or. Then after the or, we have true again. And then we have and. And after the and, we have true. So false and true, or true and true. So what will be our final answer? Now with something like this, you have to go step by step. Okay. So first you take
Okay, the first. Okay.
the first two.
The first two.
So true and false and true will give us what?
False.
False.
Yes, sir.
So false or true.
Or true.
And
True. Yeah.
And true. Then we come to the next step. We come to the next step. And then we take the
True.
next two. So false or true will give us what?
True.
Will
That's
give us
true.
true. So
Yes.
true and true and true. So true and true will give us true. So our final answer Yeah,
True.
it's true.
Yeah.
Okay.
Well
Yeah.
understood.
I like the way you are all contributing to this. So next week when we meet face to face and we have a quiz, I believe we'll score full marks.
Yes.
Yes, sir. Yes,
Yeah.
sir.
Yes, sir.
I like
Yeah,
the
can you
view.
go over? Can you go over?
Oh,
Go
no.
over.
Okay, so the person asking will go over. The video will be made available tomorrow. I'll share the link with your class rep so that you can watch it over again.
Okay, sir. Okay.
Yeah.
Okay, sir.
Okay, sir. Okay, sir. Thanks.
Okay.
Thank you.
All right. So I would like to end the class here. I'd like to end it here. Next week we'll talk about the selection control statements, and then we'll start looking at these examples, how to write the flowcharts and how to draw them using the draw.io software.
Why don't you end at not?
Oh, sorry, I left the not out. Sorry. Thank you. So let's talk about the nots quickly. So the not simply means not. Okay, so anytime we use the not, what it means is that if the expression is true, so for instance, if A is 2 greater than B, which is 6, if this is false and we are saying not true, then it means that it is, sorry, not false, then it means it is true. And if you have an expression that is true and you say not true, that will give us false. Okay. So for instance, the example that we had, I can put the entire expression into brackets and put a not before it. So I think we had F and T, or T and T. Okay. So if I put all in this, our final answer was what? T, which was true. So if we put the not there, it makes a statement false. Okay, so basically that's how the not true works. Okay, and when we start writing the program, we realize that in C++, we use what we call the double ampersand symbol, the and symbol, to represent and. The or is the double bar symbol, then the not is the exclamation mark. Okay. All right. Wisdom, you have a question? I'll take your question and then we'll call it a day.
Good evening, sir. So my question was about the example you gave, and then the reply my colleague also gave, where A was 2, B is 6, and C was 4. So the first statement means that 2 is less than 6, which is supposed to be false, but he said, which is supposed to be true, but he said false. That was when I raised my hand to correct that.
Okay, but I think we corrected it along the way, right?
I don't think so.
Oh, really?
Yes.
I think we corrected it because everyone was following. I don't think
Oh,
we made a mistake anywhere.
okay.
Because
Oh.
later on, was it with what I wrote or the example we have on the screen?
The last example you gave about and not all together.
All together. Oh, I did it. I did it A. I did it A is greater than B. Maybe you didn't see it well.
Oh, okay.
Yeah, I did it A is greater than B, which makes it false.
Oh, okay.
Yeah, so that was how come we had false at the first instance. The first expression gave us false. Yeah.
Oh, okay, sir. Thank you.
Okay. All right. Yeah. What else? What else? What else? Anyone? Okay, I see a hand up, Paul. So I'll take Paul and
Yes,
then
sir.
Daniel, and then we end for today.
Please, thanks for the opportunity. My question is that are these operators, both the logical operators and the first operators you taught us just now, are they HLL or LLL? Are they machine language or high-level languages?
All right. So, like I said, what we are learning now is independent of any programming language. It doesn't depend on any programming language. Okay, so for now, don't look at it in the context of a programming language. Okay. The other thing too I'll say too is that it is how do I put it? Our focus at this level is on object-oriented programming language. That's the 4th generation. Okay, so all the things we will be learning or we are learning now, it will be tailored towards the 4th generation. That's the object-oriented programming language. We are not going to learn anything binary language or assembly language or the other one. Okay, so those ones were just to give you an idea of how programming language evolved over the years. Okay, but we are focusing on the 4th generation programming language, which is object-oriented. And for this semester, we are looking at C++. That's our primary programming language. All right, Daniel.
Okay, sir, please, can you go over the logical operations? Can you go over the not?
Due to time, I'll plead with you to watch the video when it's uploaded.
Okay.
Yeah. Is this Stephanie or Steven?
Yes, please.
Is this Steven?
Please, it's Stefan.
Stefan. Okay, Stefan. Yeah.
All right, thanks for the opportunity.
Yeah.
Please, I just want to ask about the handouts, if they will be available.
Yes, they will be available next week.
All right. Thank you very much.
Okay, so Timothy, so any of your other information will be communicated to your class rep on that.
Okay.
Yeah.
Okay, sir.
So let me take, okay.
Sir, please,
So I think, pardon? Did someone say something?
Sir, please, I wanted you to make some more details for me. Before the logical operators, the table before that, I think the relative operators. I wanted to ask a question on that.
Okay. By the way, SL, right?
Yes, please.
Yeah, we know you are using iPhone. Okay, so we want your full name.
I changed the name.
As what?
Please,
SL's iPhone.
No.
Yeah, we know you are using iPhone.
The table, they're not equal to. If I heard you right, you said we can use the exclamation or the equal to instead of the asterisk, the hash.
No, I'm saying we can use. Yeah, I think I was saying that we'll go more with this one, the exclamation with the equal to, rather than the hash. Okay. So in writing our programs, let's stick to rewriting our algorithms. Let's stick to this one, as well as when it comes to the equal to. Let's stick to this. Yeah.
Thank you very much, sir.
Okay. All right. All right. So last week I'll stop recording now. Bye. All right, so